All right, hi everybody. So we're going to take a look at solving some exponential equations, and these problems are going to go from easy to medium to hard. So the first problem we have is going to introduce a strategy that's going to be used pretty consistently throughout, and that is finding a common base. You may recall this from last year. So we have to solve 3 to the power 5x is equal to 81. Now this is nice and simple for us because 81 is, of course, 3 to the power 4. We know that because we've done enough exponents of 3 to be able to get ourselves there. So we can simply replace 81 with 3 to the power 4. So we'll have 3 to the power 5x is equal to 3 to the power 4. Now, once you get to this spot, you can do much like every poor dubstep song from the late 2010s and drop the bass. Now, you can only do this base dropping thing if you have an exponential term equal to an exponential term. There can only be one term on either side of the equal sign. If you have multiple terms, you have to find another strategy, which we'll see in the hard problem. So when we drop the base, we write an equation of the exponents. So this would be 5x is equal to 4. Because if 3 to something is equal to 3 to something else, then something must equal something else. And we can do a quick division, and that tells us that x is equal to 4 over 5. And so that is how we solve an easy problem. Next up, medium. So this is a medium problem because it's similar to the easy problem in that it's got only one term equal to another one term equal to another one term. But it's a little bit more challenging because the exponential term isn't isolated. So your goal for these medium problems and for many problems is to actually just isolate that exponential term so that you can take advantage of the whole drop the base concept. So we're going to isolate that 2 to the power 3x. We'll do that by dividing both sides by 3. So this will get us 2 to the 3x is equal to 4. And right away, you can see how this medium problem turns to an easy problem quite quickly. We, of course, know that 4 can be written as a power of 2. So this would be 2 to the 3x is equal to 2 to the power 2. And then lastly, we can drop the base and write 3x is equal to 2 and do a division to show ourselves that x is equal to 2 over 3. Now with these easy and medium problems, a hitch that we like to throw into them is having a quadratic in the exponents. But generally the problem stays the same until you get to this drop the base portion. And then from here, you'll either have a linear term or a quadratic term or some other argument that you'll have the algebra to get to a final solution for. So that was a medium problem. Next, we'll take a hard problem. And so in yesterday's work, which is now 2 days ago's podcast that was played yesterday for the first time, confusing. But in yesterday's work, I had talked a lot about factoring and how factoring strategies are often going to show up. And they'll show up in different contexts. Now, this doesn't quite look like a quadratic, but it is. Now, a good hint that something is going to require factoring is that it has 3 terms. We recognize that from our trinomials. So to solve this problem, we're going to have to set up and do some factoring, but first we need to rearrange. So we'll rearrange this 2 to the power 2x so that it becomes 2 to the power x squared. And I can do that because of one of my properties of exponents. Now I'll leave the rest of this exactly the same. And depending on how you solved exponential functions in your grade 11 course, you may have done substitutions for these. And you may recall seeing things like let a equal 2 to the power x. So now I have a 2 to the power x there and a 2 to the power x there. And if I rewrite this, this becomes a squared minus 3a minus 4 equals 0. Do you see where the factoring is going to come in handy? Because now I need to solve this equation for a. Of course, this factors quite nicely as a simple trinomial. So it'll become a and a. The first sign is negative. The second sign is positive because the signs are different. The factors of 4 that make 3 are 4 and 1. And so we now know the solutions for this. But we know the solutions in terms of a. We don't know the solutions in terms of x. but a is equal to 2x. So we can back substitute. So we'll have 2 to the power x minus 4 and 2 to the power x plus 1 being equal to 0. And so this means that one solution is 2 to the power x is equal to 4. Well, that's a fairly easy exponential function to solve, or exponential equation to solve. 4 is 2 to the power 2, as we've seen before. And so we have x equals 2 as a solution. So x equals 2 actually solves this equation up here. Let's try it out. 2 to the power 4 minus 3 times 2 to the power 2 minus 4 is equal to 0. Okay, 2 to the power 4 is 16. 3 times 2 to the power 2 is 3 times 4, so that's 12. So 16 minus 12 is 4, and 4 minus 4 is 0. So yeah, that works. That's one solution. Now, there could also be another solution from here, but this implies that 2 to the power x is equal to negative 1. Now, I don't know about you, but in our discussion about logarithms today, we had seen that there's really no exponent you can attach, or no real exponent you can attach to a number to change its sign to a negative. So in fact, this yields no solution. And that's solving easy, medium, and hard exponential equations, sorry.